You know, we usually think of truth as being pretty black and white. A statement is either true or it's false. Simple. But what if there's a whole world of logic that goes way deeper than that? A logic that cares less about if a sentence is true and a whole lot more about what it actually means. Well, today, we're going to take a journey into that world together.
All right, here's the game plan. First, we'll take a look inside what I'm calling the traditional true-false box. Then, we'll see a full-on revolt against it, which leads us to a new logic of meaning. After that, we'll see how this whole thing creates a unified framework for a ton of different logics. And finally, we'll connect it all back to the real world.
So let's just kick things off with a simple question to get our heads in the right space. When are two completely different sentences truly the same? Now, your first instinct might be to say, never, right? But in the world of formal logic, the answer is way more complicated, and it actually reveals this deep philosophical split. And here is that split, right in front of you. In traditional Fregean logic, since the sky is blue and grass is green are both factually true, they get boiled down to the exact same value, true. Logically, you can just swap them out. But non-Fregean logic hits the brakes and says, whoa, hold on. These sentences describe completely different situations, so they must have different meanings.
Okay, so let's dig into that first way of thinking. This is the true-false box. We're going to really explore the limits of this, well, traditional logic. So this whole system is really built on one powerful idea, Frege's principle. And what it says is that from a purely logical point of view, all the rich, beautiful detail of a sentence just collapses down into one single property, its truth value. Is it true or is it false? And according to this principle, literally nothing else matters.
This quote just drives that point home, doesn't it? Think about that for a second. It's suggesting that a sentence like, "the sky is blue," is just another name for the concept of true, just like 2 + 2 = 4 is. They become the same thing because they share the same truth value. It's a really reductive but also incredibly powerful idea.
So, yeah, in this world, you're either in the true bucket or the false bucket. That's it. There's no room for nuance, no room for context, no room for the specific situation a sentence is describing. This is the true-false box, and while it's useful, some logicians found it, well, incredibly limiting.
And of course, that limitation sparked a reaction. This brings us to our second section, abolishing the axiom. A kind of philosophical revolt started brewing, and its whole goal was to break out of that restrictive true-false world.
And a key figure in this revolt was the Polish logician Roman Suszko. Now, he didn't just want to tweak Frege's principle, he called for its complete and total abolition. He basically argued that we were throwing away a huge amount of information by just reducing everything to true or false. Suszko's challenge really opens up this fascinating question. What if sentences have these secret lives? A richer layer of meaning that exists completely separate from whether the sentence just happens to be true or false right now.
And that question leads us directly to a whole new way of doing things, a logic of meaning. And this required a brand new toolkit for taking apart and comparing sentences, a toolkit that could actually see those secret lives.
The number one tool in this new kit is the idea of semantic correlates, okay? It's a fancy term, but it's just the formal name for that extra layer of meaning. It's the unique situation out there in the world that a sentence is pointing to. So, the sky is blue and grass is green have different semantic correlates, even if they're both true.
So we're basically moving from a flat, two-dimensional world of just true and false to this rich, three-dimensional world where sentences have their own unique identities based on the realities they actually describe.
Now, to work in this new world, Suszko introduced a new operator, the identity connective, which just looks like an equal sign. But this is not your standard equals. It doesn't check if two things have the same truth value. Instead, it asks a much deeper question. Do these two sentences refer to the exact same situation? Do they have the same semantic correlate? And this new connective is governed by just a few really common sense rules. First up, any sentence means the same thing as itself. Okay, easy enough. Second, if two sentences mean the same thing, you can swap them inside a bigger, more complex sentence, and it won't change the meaning. And third, if two sentences truly mean the exact same thing, well, then it has to follow that they also have the same truth value. But, and this is the key, the reverse isn't necessarily true.
Now, this new approach didn't just create one more type of logic to add to the pile. It did something much, much bigger. It created a unified framework that could actually house many different logical systems all under one roof.
The real power of this whole thing is how inclusive it is. Instead of just throwing out the old systems, it creates this big tent, a broader perspective that can hold both classical logic and tons of so-called non-classical logics. And it lets us see how they all relate to each other.
And I mean, this framework can organize a huge variety of systems. We're talking about logics that deal with possibility and necessity, others that go beyond true and false to a third value like unknown, and even logics that are designed to handle contradictions without completely falling apart. They all find a home here.
So what's the end result of all of this? It's a massive upgrade. By moving beyond a simple true-false binary, we get a logic with far greater expressive power. We get the ability to talk about and analyze much more complex and nuanced ideas about the world.
Which brings us to our final and maybe most important section. Why does any of this matter, right? How does this abstract logic stuff actually connect to the real world? Well, the answer is all about situations and semantics.
That non-Fregean idea, that sentences refer to situations, it gave birth to a whole field called situational semantics. And this is where logic meets linguistics and cognitive science. It's built on one core principle. Context is everything when you're trying to figure out what something means.
And the practical applications here are really profound. In AI, it helps machines understand the context of a story. In linguistics, it gives us new ways to tackle ancient puzzles like the liar's paradox. You know, the sentence, "This statement is false." By focusing on the situation, we can escape that logical trap. And in cognitive science, it helps us model how our own decisions change when our context shifts.
So if there's one thing to take away from all this, it's this. By breaking out of that true or false box, we discover that logic can be so much more. It can be an amazing tool for understanding not just abstract truth, but the messy, context-dependent, and deeply meaningful way we actually think and talk to each other.
And that leaves us with a final thought to chew on. The story of non-Fregean logic is really about challenging a fundamental assumption, a simple binary we took for granted. So it makes you wonder, if logic itself can evolve beyond just true and false, what other simple binaries in our own thinking are we ready to start questioning?